30. Done working on this individually. Your code for the poll. The code for the poll when you're doing. Why is this still? No. Okay. Try. Maybe I'll do this one and turn this one off. Okay, is this working now? Okay. So your code for the poll is 952, and do not answer the poll until you are done. So just don't open it until you have finished individually. And then when you are done individually, answer A, but only when you are done. and seems that many people are done about this. If you are still not done, you can finish when you are doing the peer discussion. So do talk to the people around you. Go over how you got to your answer. See if you're convinced to change otherwise. And then when you guys are done with the peer discussion, change your answer from A to B.
And then my code and all that is for like I still use stop that that's just first of negative This one was I did the first question to That's what
Hey, just a reminder, when you are done, switch your answer from A to B. All right, most people have switched. So let's do this one at a time. So the first question is, how does this affect the immediate value in the I-type instructions? So what's my first thing that I should look at here? It's the first thing you guys did. MIPS reference sheet, what did you look at?
the I-type instruction.
So I-type, what's the first field? Second? Third? And the last one? Opcode is how many bits? And this is 5, this is 5, this is 16, right? But we have changed our register file from 32 registers to how many registers? So does that, and we did not change opcode, right? Yep, so we did not change any instructions, so opcode, same. But for our registers, do I need 5 bits now? How many bits do I need? 16 registers. Yep. 4. And it's both for both of them, right? So then what does that mean for my immediate field? What can it become? Yep, because we're keeping instruction length the same. So we now have 18 bits. We have this 2's complement value in the I-type field. So what is my range? I have 18 bits. So it's -2 to the what power? Mhm. Through 2 to the what?
17 minus 1.
Yes. So this is my new range of immediate values that we can represent in the I-type instructions. Okay, so the next part of this question was, what is the maximum number of instructions a branch is capable of branching forwards and backwards? So what happens to the immediate for the branch instruction? Not add 4, but multiply 4, right? Because the last two bits are always 0, 0, because our instructions are word aligned. But then we can just kind of ignore that because that just gives us the address, but in terms of the number of instructions, it's the same as the immediate field, right? So that means that we have this range, right? So -2 to the 17 through 2 to the 17 minus 1. But what happens to PC before we add this immediate? Yeah, so it moves forward by 4, which is 1 instruction, right? So I need to, for the backwards, I can't go as far, right? So for backwards, so back, it's 2 to the 17 minus 1 instructions that can go backwards. Forwards, it's 2 to the 17 minus 1 plus 1, nothing. What do I put here? It's actually nothing because, right, you have -1 here, but you are basically +1 from the PC plus 4. So they just cancel out. Right? So this is our forward and backwards range in terms of number of instructions. If we were talking about address space, you would need to multiply these by 4. Right? All right, so here's the next question. So translate the following MIPS instructions into machine code in binary and then translate the binary into hex. So we should have an 8-digit hex for each of these instructions. And when you're done with this, individually change from B to C. See everyone, well, not everyone, but a lot of people are still working on this. But just in the interest of time, we need to move on. So do talk with the people around you and start working together on this to finish. And then just when you're done, like as your small group, then move your answer from B to C.
Excellent. Yeah.
It's 952. So from B to C when you are done with the peer discussion. Do not do it now. So if you've moved your answer to C already, move it back to B, please.
Yeah, I think this course has the number of style things the RT. I split them up. So for the first six, I would make it into 13 for the binary. Right, that's up to very end. I kind of think the 27 and add up to reserves to me, and it fills the whole 16. But then again, you get scrubbed, but just the work. So pretty much once you get on work, turn into hex, I got my brain. And that could be correct, or my brain could just be frying. But I try to convince what I want to It's just. Luckily, we'll have like a reference sheet on the site that I already looking at this, that I sent it on. And then the rest of the zeros, please say that have a full 16 digits, almost in the sign extension for the icon to observe. The story word, symbol, style, all of the story word, so it's gonna be 27. I think it's gonna be great. Pretty much along that you have that 16 bits. Yeah. Yeah. It's almost like it's still another one. Okay. First one, it's a kind of second formula 001. And then I see the hex, so I started once again with top code 2B. So that's it hex. So it's 32 plus 11. Just 43. 11. So impacts, you know, the ones training only 16. And I like my narrative 32 is 18 cents. 216. 32. Red version 1. 16. It's a 16 cents. Maybe that would be.
Just a reminder to move your answer from B to C when you are done as a group.
First part.
Okay, so let's work on doing this together. So ORI, when I'm translating this instruction, what's the first thing that I'm going to look at? Opcode on my MIPS reference sheet, right? So I'm looking for ORI. So ORI is OR immediate. And its opcode is what? D. Right? So what is D in hex? 13, right? So then I also see that it is an immediate type. So I have the format opcode RS RT immediate, right? And this is 13. RS is which one? T0 or V1? And V1 is which register number? Yep. So this is 3. RT is T0. T0 register number is
8.
And then I need to put 27 in the immediate. Okay. So now I need to write this in binary. So my opcode is 13 and my opcode is 6 bits, right? So then I need a 1 here, 1, 0, 1. Right? But I'm just going to kind of bunch them up in 4 bits. So it looks like that. And then RS is 3. RS is 5 bits. So 1, 2, 3, 4, 5. And then RT is 8. And it is also 5 bits. So 1, 2, 3, 4, 5. And then immediate is 27. So I need 16 bits. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. So this is. And then I need. So 16. And I need 11. So 1 and 1. Right? So now I need to translate this into hex, right? So I've already bunched them up into 4s. So this is just going to be in hex. This is 3. This is 4. This is 6, 8, 0, 0, 1. And this is 11, which is B. So 0x 3, 4, 6, 8, 0, 0, 1, B. Probably the most common mistake is not doing this opcode as 6 bits and doing it as 4 bits, and then like the first digit of your hex, some people might put D. So that's, I think, the most common mistake. The other common mistake is swapping RSRT.
Real quick, why B1 is RS?
So looking at the MIPS reference sheet, on the OR immediate, it's RT is equal to RS or the 0, like the sign extended, the 0 extended immediate, right? And we know that the first one here is destination in MIPS. So that makes it RT. Okay. MIPS format is for the assembly, destination, and then operands. You can also memorize that RS is never a destination. It's only ever RT or RD. All right. So next one, store word. Again, first thing I'm doing is looking for store word, right? Store word is what opcode? Right, so it is 2B, and we have opcode. Store word is again an I type, so RS, RT, and immediate. Okay. So what's RS here? Yep. So A0 is which register? And RT is register 9, and then immediate is 8, right? So 2B. So if I translate this from hex, I would get, and then B is, right? But again, this is only 6 bits, so I don't need those first two. So it's 1 0 1 0 1 1, right? RS is 4 0, oh, and I need 5, so 2 3, and RT is 9, so I have 0 1 0 0 1, and then I have immediate. I need 8 2 3 4 1 2 3 4 1 2 3 4 2 3 4. So again, translating to hex, this is A, right? This is C. This is 8. This is 9. This is 0 0 0 8. So 0x A C 8 9 0 0 0 8. So this kind of question will be on your exam. You need to be fast at it because it's not a whole lot of work to go through. What takes time is looking through the MIP sheet, right? So you need to be familiar with the MIP sheet. So between homework, examples on the slides, and these questions, and you can also make your own, right? You need to become more familiar with the MIP sheet, right? So we do have 5 minutes. I'll just leave this up for you guys to work together. We won't have time to go over it, but you can spend the next 5 minutes translating this. And just as a hint, A0 looks like it's address of an array.
Oh, that's not fair.
All right. So just in case you weren't looking, I did write down the answer. It just loops through the array, checks if the element is not equal to 10. And if it's not equal, it loops to the next one. And then if it is equal, that means I don't branch. So then I grab the indexing variable, which is T1, and return it. But I also -1 because I was incrementing it before. Right. So there is reading for Friday. You have exam on Monday. The exam will only cover the stuff that we have done for homework 1 and what we have reviewed. So the stuff on Friday is new material that won't be on your exam. You have homework due on Friday, and you have the exam study guide if you choose to do it, due on Monday before class.